Hi guys, my name is Dmitry Ulshansky. I'm geotechnical engineer and hydrogeologist. I have two majors. Uh, I'm going to discuss today Pressuremeter test, and this one just for designers only. That means how to analyze, what to do, if the results are good, bad, reliable, not reliable. Okay? So we are going to discuss today uh, actually two pressuremeters tests, two pressuremeters, Menard and Texan. Both of them are used and carried in pre-drilled borehole, special hole. Definitely you have different types of direct pushing, self-boring pressuremeters. We are not going to discuss it today. So both Menard and Texan pressuremeters using liquid and measuring volume change only. They are not measuring diameter. Even if you see results and you can see some reports in axis uh, delta R, like just a minute. So you can see O volume, or you can see delta R change in diameter divided by initial diameter, multiplying 100%. That means it results in percentage. Actually, these values are imaginary. It's pure math. It's not real measurements. What they measure, just volume, cc, cubic centimeters. So for designers, please don't design your tests by predetermined intervals, 2 or 3 meters. What I suggest you to drill borehole, first of all, geotechnical borehole, find out the layers, the thickness of the layers, and then design your pressuremeter test. What I mean, for example, if you drill boreholes and you do know approximately you have 3 meters of fill, for example, then you have additional layer up to 12 meters sand, and then you have clay up to 17 meters. So what you can do, you can make one test 1.5 meters, then maybe 5 and 9 meters tests, and you have 5. It's either you can do one test in the middle, somewhere, let's say 15 meters, or try to do two of them, but it's a little bit difficult from practical point of view. And then at the end of the day, you get representative tests at the depth of 1.5 meters, 5 meters, 9 meters, and 15 meters. And all these tests is going to be in the middle of the layer. If you are going to make blindly predetermined depths every 3 meters, that means 3, 6, 9, 12, 15, and 18 you cannot because you don't know what. So what is going to happen? Test number at 3 meters and 12 meters is going to be exactly in transition zone between two layers. How are you going to use these numbers? I have no idea. Except the only option you can do this way, if you have only one borehole, that's it. Maybe you can use it. I never ever understood how to use this type of information because it's kind of transition zones. So I just would like to show representative what output for pre-bore pressuremeter and self-bore pressuremeter. Differences are only in the beginning. So you don't have in self-bore pressuremeters test initial curve because actually self-bore pressuremeter or pushed in doesn't have gap between your probe and borehole wall. And actually in many cases, like if you just take a look this case, Actually, you don't have ePMT. You missed it. So the only thing what you do, rebounds when you can calculate shear models, but not PMT models. Okay? That means you have to make some back calculation from G to E. So let's go. So this one representative classic very good test of Pressuremeter test. If you make straight line in linear zone, you get 2 points. These 2 points divide whole Pressuremeter test into 3 zones. Zone number 1 or phase 1, probe inflate in air or in drilling mud, in water. That means before it touch borehole wall. The second one, very important, what we're looking for, is zone number 2, phase number 2, elastic zone. And the last one, after it start flying, you have zone number 3, phase number 3, plastic zone, when you actually fail your soil. Let's see how you calculate a model of Pressuremeter. You take tangent to original curve, pick up 2 points on this linear zone. I would suggest you not pick up in the beginning these 2 points and then the end. Just make between them inside, just to make sure you literally calculate models, elastic zone. And you have tangent, delta V, delta P. That means for each point AB you have VA, VB, PA, PB. You have calculate delta V, delta P, and you calculate your model of elasticity. Exactly the same approach you have to apply for calculation E rebound. The only thing you have to pick up 2 points in rebound curve portion. What I would like to suggest to you, because many consulting or some engineers or textbooks suggest that if you have this rebound and they calculate kind of unloading, reloading tangent, and then some average. I couldn't understand, except for theoretical approaches or something modeling, how can I use it? So I keep it simple. If it's rebound, I just take 2 points or between if it's like not exactly and calculate some average tangent. That's it. Yield pressure. Yield pressure actually is the point when your linear portion of Pressuremeter ended. Let's take a look. So again, Pressuremeter test, you take tangent. The last point which coincide with curve of Pressuremeter test and straight line, linear zone, and projection on pressure axis, it's your yield pressure. Pretty straightforward. We are going to come back to yield pressure because we need it. Limit pressure. Limit pressure, it's actually pressure when your soil is failed. How do you calculate it? Okay, we're taking the same curve, calculating volume, which is going to correspond to pressure limit or limit pressure. How do you do it? You again make tangent line, you take a point, volume of at this point, which actually is the first point started your linear elastic zone, multiply by 2, and adding volume of your Pressuremeter probe. We know it actually, it's like from manufacturer, you have to find out diameter, length, and some initial VI, which we are not discussing, and you calculate V naught. Then you take volume, which corresponding to limit pressure, to the chart. make projection on the extension of your curve, because sometimes you cannot get your curve to this specific volume because of limitation of device or anything else, or pressures, maximum pressure applied during the test. Make projection to the again to pressure axis, and this one limit pressure. Pretty straightforward. Limit pressure later could be used for calculation of bearing capacity of footing foundations. Another way to calculate limit pressure is to take all points beyond yield pressure and build it in specific scales, another format. So what you're taking invert values of volume, all these 5 points, and the pressures, connected by straight line, and vertical scale of volume is logarithmic, you can see. Again, calculate volume corresponding to limit pressure. Put it horizontal line to the intersection with your straight line connected points. Find the point C on line and make projection on pressure scale, and this one limit pressure. It's another way. I would strongly suggest you to use this approach. It's more accurate and it's more like it's mass calculation. Previous techniques, it's a little bit subjective. We are going to discuss it later. K-naught value, very important coefficient. Every geotechnical engineer wants to know why K-naught, and definitely we can use K-naught as a 1 minus psi or another way, or if it's over-consolidated material or not, but how to get it from Pressuremeter? So unfortunately, different textbooks providing different information, different suggestions how to calculate. And because of that, you have different K-naughts for the same curve. Let's see. So you can see some representative curve. The first approach, you take tangent to beginning of your curve of the Pressuremeter test. Find the point which the furthest point intersecting, overlapping the straight line, tangent, and your curve. And make projection to pressure axis, and this one of your horizontal stresses. Another approach, you take two tangents, tangent to linear and tangent to initial curve, find the intersection, bisect it, make projection to the curve to getting another point, and again project on pressure axis, and this one sigma 0 horizontal 2. And now the last approach, what some textbook suggestion, it's take tangent line to initial linear line, make the point and projection on pressure axis. Okay, so it's this one way, and you can see, as you can see, you can get 3 different K-naught values. So my personal experience, I would suggest you, or I would use sigma 02. It kind of makes sense for me the best. But again, everyone can make his own decision. So Young models. So it's pretty straightforward. Whatever you're getting from Pressuremeter test, ePMT, or E-rebound, divided by alpha coefficients, is going to provide you Young models. It's according to different textbooks. It's what actually Menard did first. And Menard suggested how like it's empirical coefficient, alpha coefficient. What's the funniest part? I have original from Menard manual 1975. As you can see, don't exist alpha parameters for overconsolidated or weathered or remolded materials. I cannot explain, I could not find who first put all these parameters. For me, they don't have any sense. And because generally Pete, it's normally consolidated. So I would agree with Menard table rather than another tables. Also, I never could find who first introduced rock alpha parameters. And what the last term is the last stuff is like Menard originally called it alluvium. In latest textbooks, it starts somehow called silt. Don't ask me, I don't know what was the reason behind that and what was the explanation, okay? Now, I just would like to show you good tests. This one, what you're getting. And then you have two different bad tests if the borehole for Pressuremeter test was not prepared properly. That means, or it's too tight, it's one, or it's too big, I'm sorry, too big, or it's too tight. That means you have or this portion when it's too big, or you have another portion. Common sense. In both cases, a test not good. Let's see real tests and how to analyze it. So this one perfect test, everything fine. And EPMT and rebounds, one test showing you like you have just 3 rebounds, this one rebound. Honestly, I never ever could understand why people doing 2-3 rebounds. Why? Because you excavate and build up your building. You never ever excavate, fill it out. Excavate, fill out. So for me, I would use every time the first rebound rather than second and third. Based on experience, when we carry out many tests, the second, third, nth rebound every time getting higher value by definition and just by common sense. It is the same happening in triaxial tests and the same happening in consolidation tests. More rebounds, the higher values you're getting. Okay, so this one bad, I put it like kind of it's bad, it's not bad, it's good test, but definitely what you can see, all these tests, it's actually very tight. That means you missing all first part, like all first part. It doesn't exist. So I would question horizontal pressure. And we will discuss it about later. Okay, it's good taxon. But I just would like to point you, okay, so one technique that was used, inverted values of points of volume, it's everything fine, and pressure limit. But if you take only 5 last readings and build tangent to this one, you can see a little bit different. So it's sensitivity, so you can increase your limit pressure. Another example, again, you make a tangent. In this case, I wouldn't see it all if we don't have in this specific case, it start bending, start failing the soil. So I think you have question limit pressure if it doesn't exist. Just for your information, generally dense, very dense, non-cohesive material, silty sand, sandy silt, sand with silt, sand, fine, coarse, sand with gravel, when it's dense, so blow counts more than 50 of SPT, you generally cannot fail the soil. You just densify it during the test. So it's pretty common not to get limit pressure in non-cohesive materials. Another example, it's even worse or not worse. It's a very good test. But guys, I wouldn't believe any values which consulting or whoever tester is going to provide. You don't have here limit pressure. You can kind of use it, but it's going to be just fiction, okay, not real. The same, another example, no limit pressure. And also here, the same situation. Guys, you like this number or this curve, I would question 1,000 times. And you can increase this way, or you can increase even this way. Everything is going to work. So guys, whatever you're getting limit pressure, I wouldn't rely on that, okay? Now, about cannot value. Do you remember we discussed there is three options, sigma horizontal 1, sigma horizontal 2, and 3? Guys, very famous for Texan Pressuremeter have this kind of bend in the beginning. I discussed it many times with rock test representative Louis. I can explain it, but today it's not the issue. I just would like to show you, so we have one tangent, another tangent, third tangent, all of them, like you get absolutely different. Okay, maybe the first one, it doesn't make sense, but what I'm saying, you cannot use these approaches. So the only approach you can use, first point and linear section of the Pressuremeter test. It's the only, yeah, but it's again, it's up to you, decide if you trust it or not. The second point, for example, for the same test, choosing 2 points to calculate models of PMT. If you just make straight line, I cannot see how people pick up these 2 points. Then definitely I wouldn't use it this 1 point, I would use another, like when I circle green one. And pressure limits. You can do this way, you can do another way, so it's all pressure limits is going to be valid. So I would question about pressure limit, especially for this specific test. Conclusions. For this specific test, you can trust, you cannot trust EPMT, limit pressure, ratios, the second ratio, and P naught. If you take a look at these 3 points, if I were the tester, I would remove them. Guys, sometimes or very often, not sometimes, very often, doesn't matter what test you're going to do, triaxial consolidation, pressuremeter, doesn't matter. You have some points, garbage points. Don't use them, just toss to the garbage bin. Actually, this one's the tester responsibility just to look and see not reasonable points. I don't know what happened during the test, but definitely these points don't have any sense and they're not, they should not be on the chart, okay? And then I just would like to show you another example. You can see it's one side, we like ordered Pressuremeter test, consultant came and carry out the tests. We told, no guys, it's bad test. They argued with us, tried to convince us it's good test, and we forced them to repeat it by another consulting company. And look at this one, it's the same depth, the same location, it's absolutely different. So it's 10 times different, and pressure, limit pressure, and EPMT. So what I would like to tell you guys, if you see so bad test, don't trust it. Like, even doesn't matter what written in the table, it doesn't make any sense. So you have this one 10 times difference for good test and like bad test. The same site, the same depth, the same borehole, like first test, first trial, another borehole, and again 10 times. So if you see not good shape, the test is not good. Doesn't matter what test you're going to do. Gradation, attribute limits, triaxial, consolidation, pressuremeter, load point test, load point test not like test on rock samples. Doesn't matter. If the shape not close to classic or something, I mean, don't speak about several points. Don't take into account these results. And last, I would like to discuss, it's about groundwater level. You can see 4 tests results, the same borehole, and each borehole, if you just take a look, so it's like shallow depths, deeper, in the deepest point. You can see every time in this location, it's every time moving up. And it will be correct, just one condition. You see the trend, the deeper test, the high initial pressure. It's totally correct if the borehole is dry. Why? Very simple. The liquid inside the tubes make additional isostatic pressure on the wall of the test hole. But it's absolutely, totally wrong if you drill your borehole using drilling pump. Because in this case, hydrostatic pressure outside of your tubes, drilling mouth, and inside tube almost equalize, make equilibrium. So you don't have any additional stress on the wall. That means for this specific borehole, it was drilled with drilling pump. All initial points, all shapes should be shifted to the same point. So it's the same results, but it's everything shifted. And as if you don't do that, that means every time cannot value is going to be changed. Why? Because initial sigma 0 horizontal is going to be the deeper you're going, the higher you're going to get. But it doesn't make any sense. So it's what I would like to mention. Thank you very much for your patience. If you have any questions or you would prefer or would like to see another presentation, specific subject, I'm like kind of did this stuff, let me know through LinkedIn. Have a nice day. Take care.